All right, next question says, prove or derive the formula for the derivative of inverse cosine of x. All right, so to do this, we want to think of y equals cosine inverse of x, right? And so cosine of y is equal to x, right? If you take cosine on both sides, that's what you get. So then from here, we ddx both sides. This is an implicit differentiation situation. We did this when we derived the formulas for the inverse trig functions. Derivative of cosine is negative sine. Slap it with a dy dx because it is implicit. That's equal to 1. So the thing we're looking for is dy dx, right? The derivative of y with respect to x. Okay, so dy dx is equal to negative 1 over sine y. Question is, what is sine y? That's where we do this, all right? If cosine of y is equal to x, that means we're dealing with this situation. Our angle is y, and adjacent over hypotenuse is this, right? That means our opposite is radical 1 minus x squared, right? So d dx of cosine inverse x is going to be negative 1 over sine y. Sine is opposite over hypotenuse, 1 minus x squared, and that's our formula. Part B, find the derivative of h of x. Using that formula, d dx h of x is going to be 1 over negative radical 1 minus, then we put the argument 1 minus 3x quantity squared times the derivative 1 minus 3x. Okay, so we end up with a 3 on top. Negative times negative is positive. If you want to follow that out, we get 1 minus 1 plus 6x minus 9x squared. Okay, so that's 6x minus 9x squared. Okay. Domain of h of x and its derivative. So the domain of h of x, we know that, as we see here, x is the answer you get when you take a cosine, which is the input of the inverse cosine, right? So therefore, it's going to be negative 1 to 1. That's what it always is for inverse sine and inverse cosine, right, for the argument. The only problem is that our argument is not an x, so we got to replace that with a 1 minus 3x. Okay, so let's subtract 1. Divide by negative 3. And write it appropriately. Now, I can let you know that whatever our answer is for the next one is going to mirror this. Now, what was our derivative in this next, what is our derivative? Our derivative is this, right? Now I'm going to focus on this aspect right here because you'll see that it leads us to where we just were. Now, since that's in the denominator, I need 1 minus quantity 1 minus 3x squared to be bigger than 0. Not bigger than or equal to, just strictly bigger than 0. Okay, so if that quantity is bigger than 0, that's equivalent to saying 1 minus 3x squared is less than 1, right? If we just move this to that side, okay? But if that's less than 1, the only way that something can be less than 1, something squared can be less than 1, is if it lives here. And if it's less than, strictly less than, then it has to live inside here. The only things that are less than 1 are things that live inside that range, less than 1 when you square them, right? And so that leads us to this. Okay, without the equal to, just strictly less than. So like I stated, that's exactly what this is. And so this thing. And so that's going to lead us to this without the equal to, just strictly less than. All right. Always happens. Now, limit is not going to be the same. It's not always going to be that they're the same value, right? When you take the limit, it's going to be different. So cosine inverse 1 minus 3x. Well, let's dt. And we get cosine inverse of 1 minus 0, which is 1. Cosine inverse of 1 is going to be equal to 0 degrees, or 0 radians, I should say. Limit x approaches 0 of the derivative would be 3 over 6x minus 9x squared. Okay. And that's not looking good, but it's going to essentially blow up to infinity if you approach it, depending on what happens, right? So let's look at that denominator. X times 6 minus 9x. 0 from the right. If we're looking at coming in from the positive angle, that's going to be, let's see, so that's going to be positive times, if I'm approaching 0 from the right, that's going to be positive as well, right? Approach from the left is going to be negative times positive. So approaching it from the left is, we're not going to do that because we can have a negative in the square root. So we're approaching it from the right. And as we approach from the right, we blow up. And so we do get infinity from the right. So let me just put it this way. Equals infinity. Limit x approaches 0 from the left, d and e. So these together, limit x approaches 0, d and e.